The sixth planet from the Sun, the ring giant, holds a special place of intrigue and wonder. The jewel of our solar system, Saturn. Over the years, we've marveled at its stunning rings and mysterious moons. But what about the changes Saturn itself undergoes? On October 15, 1997, the space probe named after the Italian-French astronomer Giovanni Cassini was launched to study its destination, Saturn. Over the course of its mission, Cassini made countless groundbreaking discoveries. It studied the composition of Saturn's atmosphere, revealing intriguing details about its complex weather patterns and the famous hexagonal storm at its North Pole. And now, the James Webb Telescope has used its powerful instruments and cutting-edge technology to study Saturn in ways never before possible. Welcome to Lab 360, it's time to explore. Make sure to click the subscribe button to stay up to speed on the latest discoveries in space. The James Webb Space Telescope, NASA's next-generation space observatory, has provided us with unprecedented insights into the mysteries of our universe. Today, we delve into the fascinating seasonal transformations of Saturn. No spacecraft has ever been present to explore Saturn's late northern summer and autumn before. In one short set of observations, we've been able to continue the legacy of the Cassini mission into a completely new Saturnian season, watching how the weather patterns and atmospheric circulation respond to the changing sunlight. Observations of Saturn made during November 2022. A team led by the University of Leicester. Scientists observed a cooling trend on the gas giant caused by planet-sized airflows reversing direction as Saturn's long seasons switch. The astronomers made their observations of Saturn using the JWST's mid-infrared instrument or MIRI, which allowed them to observe the planet's atmosphere in infrared wavelengths of light just outside the capability of our eyes. MIRI let the team measure the temperature of Saturn's atmosphere and see the fingerprints of the chemicals within it, measuring their abundances while also observing the churning clouds that exist at the top of Saturn's atmosphere. The stratosphere. Known for its striking icy rings, it experiences seasons just as Earth does because, like our planet, it is tilted with regard to the Sun. Though Saturn's axial tilt of 26.7 degrees is similar to that of our planet, which is 23.5 degrees, its much wider orbit means the seasons on the gas giant are much longer than those of Earth. Saturn takes 29.4 Earth years to orbit the Sun, which leads to seasons lasting around 7.5 Earth years. The new observations by JWST give scientists insight into those drawn-out seasons and the phenomena at play when they start to shift. These observations complement data collected by the Cassini spacecraft, which observed the gas giant planet for 13 years during its winter and spring seasons. The thermal emissions of the planet's North Pole are represented by bright blue, while the color yellow represents bright and warm parts of Saturn's atmosphere. The contrast in temperatures can be seen by purple-colored areas, which represent cooler and darker parts of the planet's atmosphere. The infamous banded appearance of the gas giant planet is clearly seen in the observation of wavelengths of light in Saturn's troposphere, the lowest layer in its atmosphere. Also seen in the JWST data is a 932-mile-wide polar cyclone at Saturn's North Pole. This is ringed by a broad region of warm gases, were observed as they gathered during spring in the northern hemisphere of Saturn, called the North Polar Stratospheric Vortex. These vortices in the atmosphere of Saturn were previously observed up close and personal by Cassini. The infrared data of the JWST observations of the gas giant showed different temperature distributions in the stratosphere of Saturn than those collected by that spacecraft, which crashed into the gas giant in 2017. This is because Cassini made its observations in the planet's northern winter and spring. In the springtime of Saturn's northern hemisphere, the rings tilt slightly more toward Earth. This change in angle exposes new details, unveiling intricate structures and features within the rings that were hidden from view during other seasons. As the planet progresses into summer, the northern hemisphere experiences an extended period of sunlight. This prolonged exposure leads to increased evaporation of ice particles from the rings, causing them to become more translucent. The delicate interplay of sunlight and ice creates mesmerizing patterns in the rings. Saturn's autumn brings a transition as the ring particles are affected by seasonal changes in temperature and sunlight. Some areas become darker, while others brighten, leading to a dynamic interplay of light and shadow across the ring system. As winter arrives in the northern hemisphere, Saturn's rings begin to tilt away from Earth. This shift in perspective offers a unique view of the ring's outer regions. During this time, scientists can study the ring's structure in even greater detail. Also varying between the JWST and Cassini observations was the distribution of gas through the atmosphere of Saturn. This is the result of air rising from the southern hemisphere and crossing the equator of Saturn during its northern winter and southern summer as the NASA spacecraft made its observations. This process was reversed during the northern summer and southern winter, during which the JWST observed the planet, resulting in the powerful space telescope seeing gases low in hydrocarbons flowing from the north to the south of Saturn. Saturn was chosen as an early solar system target for the JWST to test the capabilities of the $10 billion telescope, because the bright rotating planet provides a challenge for the small fields of view for the MIRI instrument. MIRI can only look at a tiny slice of Saturn at a single time, because of how bright the planet is compared to some of its other targets, which are often located billions of light-years away. The Cassini-Huygens mission to Saturn was a triumph of human exploration and a testament to our insatiable curiosity about the cosmos. It unveiled the secrets of Saturn, its rings, and its moons, sparking a renewed fascination with our mysterious neighbor in the solar system. And the James Webb Space Telescope opened a new chapter in our understanding of Saturn's seasonal transformations. With its powerful instruments and unwavering gaze, we continue to unlock the secrets of this awe-inspiring gas giant. As we explore the intricate dance of sunlight and ice within its rings, and the ever-changing features on its surface, Saturn's mysteries continue to unfold, reminding us of the beauty and complexity of our solar system. As we look to the future, we eagerly anticipate the new discoveries that this remarkable telescope will bring, further expanding our knowledge of the cosmos. What next discovery are you expecting from Webb? Let us know in the comments below. Drop in your comments below, and don't forget to subscribe to Lab 360, because together we will explore,